Okay, good afternoon, everyone. Uh, First of all, I welcome all of you and especially Dr. Architesh Panda, who has kindly agreed to speak on uh, transition towards low carbon agriculture in Asia. And let me also give a brief introduction of our center. Uh, at NISER, we have established a DST Center for Policy Research on energy transition and tribal education, and we started this center in April 2023. And our objective is basically to work on the energy transition in eastern India with a focus on Odisha, West Bengal, Bihar, Jharkhand, and Chhattisgarh, and to basically expedite our research and also to share knowledge with each other. We have started this colloquy series, and this is the seventh colloquium that we are doing today. And we are happy to get Dr. Architesh Panda, who is currently working at OS Academy for Nature, University of Bern, in Switzerland. And I thank Dr. Panda for agreeing to this, agreeing to deliver this talk. And of course, the credit will go to my colleague who is also co-PI, in the center, Dr. Chandrasekhar Bahinipati, who is an assistant professor at IIT Tirupati. In fact, also for the information of the audience, although the center is established at NISER, we have also collaborating institutes like Dr. Chandrasekhar Bahinipati from IIT Tirupati, then Vivekananda Das from Barampur University, Saudamini Das from Institute of Economic Growth, Delhi. Then we have Dr. Gopal Sadangi from TERI, the Energy Research and Research Institute. And then from NISER also we have other colleagues from sociology, from computer science. So that's how the center is all about. Now, to give a brief introduction of the speaker, Dr. Architesh Panda works as a senior scientist at the OIS Academy of Nature at the University of Bern, Switzerland. He is an environmental economist, and his work focuses on climate change and agriculture, climate finance, climate change governance. Prior to working with University of Bern, he has worked with United Nations University, London School of Economics, Political Science, London School of Economics and Political Science, then into ICE Research Institute with a focus on climate change, agriculture, and climate insurance. So, with this brief introduction about the speaker, Dr. Architesh Panda, I now invite you to take over the floor and uh, start your lecture. And for the audience, once you finish the lecture, we'll have a question and answer session. So, yeah, with this, now I invite Dr. Panda, Architesh Panda, to start his lecture.
Yeah, many thanks, Dr. Amarendra. Can you hear me?
Yes, please go ahead.
Yes. Yeah. First of all, thank you very much for inviting me to our own, state of Odisha, NISER, so which is really good. I also thanks Dr. Chandra, who is also involved, and I know him very well. Yep, and thanks again for this. And I don't think I will take 1 hour full. So bear with me if I will not be able to cover all the time that you gave me. Yeah, so the topic that you have asked me to present is on transition towards a low carbon agriculture in Asia, which I think most of you are now at this time aware that to reduce the impacts of climate change, we need to reduce the greenhouse gases from the atmosphere, and agriculture is playing a big role in this transition towards low carbon agriculture. And on that, I will be trying to speak for half an hour or so on how can we really achieve that target. So I think many of you know that low carbon transition is sometimes equated with net zero emission, which is kind of this phrase word we all use to reach that point where we balance the earth emission and reduction of greenhouse gases. So, with that small brief introduction, I will start. Well, we all know that by this time, we all know that emission of greenhouse gases has caused global warming, which has reached around 1.1 degree above the 1850 level, and also with the with the recent,
Sorry to
hello.
interrupt. Can you come closer to the laptop or computer that you are using so that your yeah, sound will be better?
Yeah, can you hear me now?
Yes, better. Yes.
Yeah, yeah, okay. Sorry. Sorry for that. Yeah, okay. Where were we? Okay, we're in the first slide where we're discussing about how to limit the human-induced global warming, which requires us to reduce the greenhouse gas emission, where agriculture plays a big role. And I think many of you all know that in this year we're going to the COP 29, where we're going to decide that the world is really warming very fast and what to do about that. And one of the many ways that we think about this whole problem is reducing the greenhouse gases from the atmosphere. And as I told just before that, to describe the whole scenario, the concept that's most often used is called the net zero emission, which we are trying to really reduce the greenhouse gas emission. And you can see from the picture, to keep the global warming to no more than 1.5 degree, as it called in the Paris Agreement, emissions need to be reduced by 45% by 2030 and reach net zero by 2050. So that's the target we have if we want to reduce the greenhouse gas emission and reach net zero by 2050, which is really unlikely right now. And scientists are already discussing that we are crossing 1.5 degree threshold, and we might reach 3 degree already by the end of this century if we are going as business as usual. Yeah. And towards this, as we know, we're talking about how different countries are emitting greenhouse gas emissions. So it's not only India which is contributing towards the gases from the different sectors. We have a lot of countries in Asia and also throughout the world which are contributing towards the greenhouse gas emission. And you can see from the slide, I hope the slide is visible, right? Yeah, Amrendra, can you hear me? Yeah, okay.
Yes.
So you can see here that overall there are a lot of countries like China, United States, India, and Indonesia and Brazil which are contributing toward the emission from different sectors. As you can see here from the graph that India and China are really contributing a lot towards the greenhouse gas emissions from agricultural sector, of course, which is understandable because India and China are also depending a lot on the agricultural sector, and especially in India, we have a large agricultural sector where a lot of farmers are depending on agriculture for their livelihood, and at the same time, they are also emitting greenhouse gases from agriculture, especially methane. I think most of you know that agriculture is one of the largest emitter of methane because of the food production that it does. So you can see from the picture here that a lot of countries in the left hand side, you can see that I have described how different countries are trying to reach their net zero target, and where I have tried to show you that in many of the countries, net zero target in political pledge is still not there, which basically means that at the political level, people are not really determined to reach the net zero target by 2050. And also in many other countries, they have not yet really started to think about how to reduce greenhouse gas emission from the agricultural sector. So, as we are talking about the greenhouse gas emission, we should keep in mind that most of the countries, through their laws, through their policies, will really play a great role in terms of reducing the emission from agriculture. And as you can see from the left-hand side figure, still there are a lot of countries in Africa which are not really doing anything towards this. And India, they have net zero in the policy document, but we don't have any political pledge yet, like fully committed political pledge. It's still voluntary. We have, but still voluntary. So this is the overall situation now that we can see that a lot of countries are contributing towards emission from the agricultural sector. And in this slide, I will try to just briefly tell you guys why and how net zero emission is important, and why agricultural sector really plays a big role. And as I told before, agriculture is a major source of non-CO2 greenhouse gas emission, which basically means we all know that industry really produces a lot of CO2, But in the case of agriculture, which contributes towards around 18.4% of total emission at the global level, as you can see from the right hand side picture. So, but agriculture, it really produces more of non-CO2, which is kind of methane, as I just discussed earlier. And at the same time, we also we also are facing the challenge of feeding 1.5 billion people by 2030. So on the one hand, where we want to reduce the emission from the
Again, sorry
agricultural
to
sector.
interrupt you. I think there is some issue with the sound.
Uh,
Uh, when you come closer to the device, the sound increases. But then when you go a little far, the sound reduces. So if you can do something to the sound,
Sorry. Are we good now? Can you hear me now?
okay, better. You
No?
closer to the device so that it becomes better.
Okay, let me try again. Yep. Now?
Yeah. So like this, if you say it's better. Yes.
Okay, so we are here on the slide where we are talking about the emission from agriculture, and we just discussed that agriculture is a major source of non-CO2 emission, which is not really carbon dioxide but methane, which is a different kind of greenhouse gas, but still very important for the reduction of greenhouse gases from the atmosphere. And in the right hand side, you see that agriculture really plays a big role after the energy sector in terms of reducing greenhouse gases, which is kind of 18.4% globally contributing towards the greenhouse gases. Can you hear me still, Amrudra? I'm just checking. Yeah, and on the other hand, we have this challenge of feeding 1.5 billion people, and in the developing countries mostly, where agriculture accounts for 29% of GDP and 65% of the jobs, it's really a big challenge to balance both sides of maintaining the food security and livelihood of people on the one hand, and reducing greenhouse gases from the agricultural sector. So that's the background. Now, if you look at how the emission from agriculture has really taken shape in the last decade or the last 2 decades, let's say, you can see from the picture here that there are different sources of emission from agriculture, like burning the crop residues, enteric fermentation from the livestock sector. Then we have manure management, rice cultivation, food system waste disposal, net forest conversion for the agricultural sector, and also the use of synthetic fertilizer. But if you look at the data of the last 20 years in Asia, we can clearly see that enteric fermentation, which basically comes from the livestock sector, really has the highest share in terms of contributing toward the emission from the agricultural sector. And then we come the net forest conversion, then rice cultivation, and then synthetic fertilizer. So there are basically two or three big components that in the agricultural sector that is really contributing towards the largest emissions. And if you look at the picture of India, you can clearly see that in the case of India, it is like enteric fermentation that is from livestock sector is really big. And after that, you can see that for food system waste disposal and also rice cultivation. So if you are talking about India in this case, we can see that enteric fermentation and rice are really the two key largest contributors towards the greenhouse gas emission from the agricultural sector. This is the scenario from the last 20 years. Now, if we are talking about the share, as you can see from the slide here, that even if a lot of countries are in Asia are producing greenhouse gas from the agricultural sector, you can see that the total share is really small for some of the countries. For example, China, it's only 5.2% share to countries' total emission. But in the case of India, you can see that it's 21.2%. For the Pakistan, you can see it's 45.0%, and for Myanmar, it's 65%. So even if in absolute term there is a lot of emission from the agricultural sector, if you look at the country's share to the total emission, it's quite a bit of variation. For example, let's take the example of China, which is really very very small, which is 5.2% in terms of the whole contribution towards the greenhouse gas sector. So this is basically the whole scenario, and you can see that few of the countries like China, India, and Indonesia and Japan are really the highest contributor in terms of the greenhouse gas from agricultural sector. Now, if I look at sector-wise breaking the emission that's happening from the agricultural sector, one of the largest emission, as we all know, comes from the rice, which is the one of the biggest produced crop in Asia and also the whole of Southeast Asia. It is like one of the biggest crop, and at the same time, it also really emits a lot of methane emission. And you can see from the picture, I've just tried to depict the annual average percentage of paddy rice area from 2001 to 2015 and the methane emissions. You can see that a large amount of methane is really coming from the rice sector, and which basically means that there is also a large potential in the rice sector to reduce emission from the rice sector. However, while China and Korea, Japan saw a declining trend up to 2007 and contributed most to the total methane emission in Asia, the most prominent hotspot of CH4 emission is the Ganges River Delta in India and Bangladesh. I think many of you are aware that we are one of the largest rice producing country, and also the Ganges River Delta, where Bangladesh is also playing a big role. Along with that, we also see Mekong River Delta in Southeast Asia and in Red River Delta in Vietnam. These are the kind of hotspots of methane emission from the rice sector, where also basically means that the largest potential to reduce the emission from the rice sector. Now, if you go to livestock, uh, most livestock emission in Asia in most recent decade originated from South Asia and PRC, indicating a large mitigation opportunities, which means that if you want to reduce the emission from livestock sector in Asia, China and India will really play a big role in terms of reducing that. And if you talk about which kinds of livestock that are producing the highest emission, buffaloes and dairy cattle in South Asia contributing over 90% of growth in South Asia's methane emission in the last 3 decades. So basically, that's the two sector where lies the highest potential to reduce emission from the livestock sector. But at the same time, about a quarter of the global poor are livestock keepers, which basically means that most of the people who are emitting greenhouse gas from the livestock sector are also dependent on the livestock for their livelihood. So this is also kind of similar challenge like the food sector. On the one hand, you have people who are dependent on those sectors where they want to reduce emission, but on the other hand, they are also depending on those sector to for their livelihood. So we need to keep in mind that this is kind of a tricky problem here for us, both for rice and both for livestock as well. Now, if I come to land use change in the case of Asia and also in the case of rest of the world, as you can see from the slide here, that in the case of land use change, crops, pastures, and forest plantations are really the major three land use change that is contributing towards the emission from the agricultural sector. And if you look at the three different categories that I have put here: forest loss, forest carbon emission, and forest carbon from the different countries. You can see from here that converting different kind of lands for crop cultivation is one of the major reason for land use change and related emission, which is basically we all know as commercial agriculture. So what's happening is due to the pressure of increasing population pressure, also the food pressure, people are really converting all the forest lands into commercial agriculture, either for food crops or for the cash crops. And in this whole case, Southeast Asia really lost about 80 million hectares of forest between 2005 and 2015, which is really a really rapidly growing loss rate. And also some of the countries in Southeast Asia, for example, Indonesia, Malaysia, Myanmar, and Cambodia are hotspot of carbon loss from the forest sector or the land use change sector. And in this whole scenario, cropland expansion for agricultural production and concomitant spikes in the emission intensity has really contributed towards the emission from the land use sector. Now, if I talk about the irrecoverable carbon, which is a kind of a concept where we tell that when we talk that if we lost this kind of forest in this decade, there are no chances that we can recover the loss before 2050. So that's known as the irrecoverable carbon loss. And in this case, also a lot of crops, for example, you can see cattle, oil palm, soya, and timber pepper are the biggest driver of deforestation in Malaysia. And the right hand side, you can see how rapidly in the last 2 decades, Malaysia has really, destroyed a lot of forest because of this commercial crop cultivation, like palm oil and soya. And in the case of Indonesia as well, 70% of Indonesia's 3.7 million hectare of mangroves have been damaged or degraded by aquaculture. So basically, when you convert a lot of productive land or the forest lands for commercial agriculture or cash crops, you are really at the risk of losing the forest and losing the land, which you cannot recover before 2050 in terms of greenhouse gas emission. So this is also another case for the Asia where you can see different kind of crops and different kind of commercial agriculture, how it is driving the emission from Asia. Now it's kind of a bit different, but we are still at some level. We are talking about how much emission is really embedded in the international trade sector. That means which specifically talks about which countries are exporting how much amount of different products and how much carbon goes into those products, which is known as the total embodied emission in the agricultural sector, which basically means some countries import emission and some countries export emissions. As you can see from your right hand side graph, if you look at the import of emission, you can see from on the top, it's of course China, which is importing a lot of emissions in terms of different products, but also at the same time it's also exporting a lot of emissions to other countries, which is embodied in their products. In the case of India, we are really exporting a lot more emission than we are importing, which basically means that we are a net exporter of greenhouse gas emission in the international trade. And some of the largest product-specific trade flows of land use emission in Asia and the Pacific includes products such as soybean, palm oil, plant fibers, cattle, and wheat. So there is no really visible solution for this, but we need to think how we can really control these trade networks. I don't know, maybe through different certification schemes or different kind of schemes which really force or really induce these countries to reduce the amount of emission from this different crops. If you can really make the commercial agriculture sustainable, then maybe we'll be able to reduce this trading of greenhouse gas from the agricultural sector. Now, also complementary to this, we also, most of us know that food supply chains really is one of the biggest contributor of greenhouse gas to the agricultural sector. You can see from the graph here, I tried to give some examples which countries are really the highest emitter in terms of food supply chains. And food supply chains basically can include everything from transport to production, consumption, packaging, and end use, everything. So that's what food supply chains mean. And if you look at the food supply scenario of the whole world, food supply chains creates 13.7 billion metric tons of carbon dioxide, which is like 26% of the total greenhouse gas emission, which is really huge and large. So, so once pre and post production activities along agri-food system supply chains are included, food and agricultural activities generate up to one third of all emissions globally, which basically means that it's not only about greening the rice sector or greening the livestock sector or reducing emissions from there. It's also about greening the supply chains, food supply chains. Basically, how do you think about making the transport sector green? How do you think about making the food production more greener? How do you think about making packaging of food more greener? So it's not only one aspect that we need to make the food sector green, but also we need to make the whole chain of supply chains of food supply chains to make it greener. And as you can see from the graph here, China, India, Indonesia, and Pakistan are the really hotspots of emission from food supply chains. So this is another area where we also need to focus. Now, if you look at we talked about the problems quite a bit. We talked about rice, we talked about livestock, we talked about international trade, we talked about food, making the food supply chain greener. But what about the potential that technical and economic potential that we have to work around this? So basically, in this graph, you can see on the right hand side, I have tried to put the technical potential and economic potential, which basically means even if a lot of things are technically possible, they might not be economically feasible. So, for example, if you see, look at the right hand side picture, the agroforestry sector has a large technical potential, but it has less economic potential. Reducing deforestation has a large technical potential, like as such, but if you compare the economic potential, how much cost does it involve? It's really less feasible. So this graph basically tells you that in Asia, which sector has the highest technical or economic potential, and the highest cost-effective mitigation potential comes from reducing deforestation, biochar application, shifting to climate-friendly diets, peatland restoration, and agroforestry. So these are the highest sector with the highest cost-effective mitigation potential. And apart from that, improved rice management, as we discussed earlier, for example, by switching to dryland rice, residue incorporation, and reducing nitrogen fertilizer from agriculture, significantly can reduce the methane emission from the flooded rice paddies. I think some of you might know about alternative wetting and drying, where we're trying to control the amount of water we are putting on the land for the rice cultivation, so which is known as the alternative wetting and drying, which is a technique. So improved rice management also has the one of the biggest potential to reduce the emission from agriculture. And a 30% shift from meat derived from ruminants, such as cows, sheep, and goats, to plant-based proteins by 2050 could close half of the GHG mitigation gap. So yeah, we all know about this, how that our consumption pattern of food, for example, like meat from cows and sheep, are really one of the biggest contributor towards this. And we also need to think how we can sustainably shift our food consumption pattern. And we are already seeing, even if India, I have already seen that there are a lot of products where they're talking about what is that called, alternative meat, so it tastes like meat but it's not really meat. So we are going there, but we still need to do it very fast if you want to really change our food consumption pattern, basically the meat. Now, if I compare the whole things that I discussed on earlier side, as you can see from here, total mitigation measures and the technical and economic potential. You can see that we have four kind of, I divided all the potential areas into four. One is total agriculture, total ecosystem, total demand side, and total mitigation. So you can see that even if we have a large technical potential, in some sectors they have less economic potential, and agriculture, of course, plays a big role. Even land use change can play a big role, which is related to the total ecosystem reduction from the ecosystem change. So this is what look like for Asia if we are talking about the potential for economic and technical potential to reduce emission. Now I want to talk a little bit about how much greenhouse gas we are really talking about if you want to reduce emission and reach the net zero target. As you can see here that for the Asia Pacific region, there is a collective commitment to reduce an estimated 13.5 gigaton of greenhouse gases, or 32% of total estimated emission by 2030, which not looking feasible as of now. We are already sitting in 2024, but still, let's hope that we can do it. And the required emission levels by 2030 for the Asia Pacific regions are estimated to be around 9.8 gigaton of CO2 equivalent. So on the right hand side, you can see starting from January 2023 how much of remaining global budget we have in terms of not exceeding 1.5 degree Celsius, and which is depends on the probability, and it's like 50% and 83% chance of not exceeding 1.5 degree and 2.5 degrees. So as you can see here, we are already rapidly using the carbon budget which basically means that 1.5 degree target is not really looking good. Yeah, so to sum up this analysis on the emission from the agricultural sector, for most emission sources, a small number of countries, including India, China, Indonesia, Vietnam, and Philippines, are contributing a disproportionately large proportion of overall emission. In Asia, if you're talking about Asia, these are the countries which are really on the top of emitting countries, and there also the largest potential lies for them to reduce the greenhouse gas from agricultural sector. Now, if you try to connect the dots for the net zero challenge in the agricultural sector, you can see there are demand side problems where we talk about how do we really making the food consumption sector green. We have also supply side, how to make the international trade more greener in terms of food production with consumer behavior. So we can either look for technical solution, we can look for a transitional solution, and also we can look for structural solutions. But the challenge here for us is that many farmers in the agricultural industry are still out of reach of most of the low carbon intensive technologies and farming practices, which, for example, what NISER is working now, how to make energy transition greener in the for the tribal population. Let's say, for example, so for most of these people, low carbon intensive technologies are still out of their reach. And even if millions of farmers are still require financial assistance, there may be opportunities to reduce inefficient subsidies. I did not talk more about subsidies, but let me tell you at this point that agricultural subsidies around the world also plays a big role in terms of producing emissions indirectly, which basically means that we also need to reduce the inefficient subsidies, agricultural subsidies at different level for the agricultural sector. And I think many of you also know that finance will play a big role in this sector, and we are still lacking investment. We are talking about, let's say, for about loss and damage finance, where we are basically talking about how do we compensate people who are facing the onset of disaster. But apart from loss and damage finance, there is also a lot of need that finance should go to the agricultural sector, which basically means restructuring the agricultural sector towards making it more greener. And in this journey, I think justice and equity will be crucial. And well, we also discussed a little bit on. I don't want to go deeper on this because this is not in the slide. So as you see, there are also a lot of opportunities like in the rice and livestock sector, in the land use change sector, bioenergy sector, and also in the carbon markets. We have a lot of opportunities to reduce emissions from the agricultural sector. And to conclude, I just a few things that we talked about. Speed and effectiveness of reaching net zero will be determined by a lot of factors, and also by how these mitigation channels are affecting and interacting with each other. For example, cost effectiveness and benefits, trade-off with economic development, poverty, livelihood, agricultural productivity, and also we need to effectively manage the transition and its impact. For example, we can't really say the farmers who are dependent on livestock to reduce emission all of a sudden, because we need to have this smooth transition towards low emission livestock sector. And as we discussed, it also depends quite a bit on availability, affordability of mitigation technologies in a cost-effective way, which is still a big challenge for Asia. We are still dependent on a lot of technologies which are either not available or not affordable for the farmers. And there are also political commitment towards this. We know that this is a very tricky thing, and at the political level, people really don't want to talk about this because this is involving a lot of lives and livelihood of a lot of millions of farmers. So it's also needs some kind of political commitment, which really looks hard at this point. But we need to think how we can really develop the regional cooperation. For example, if India is producing a case crop very sustainably, how can it really transfer that technology to other Asian countries, so that this kind of regional cooperation. So this is basically the brief overview of what I wanted to talk. And Amarendra, I think
Yes.
up to you
Thank
now.
you. much, Dr. Architesh, for providing us very clear idea about how the agriculture sector is contributing towards carbon emission and what is the contribution of India to the global burden of carbon emission. And you also told us how to basically reduce actually the carbon emission. Uh, Now we shall open the floor for question and answer, comments, discussion. So you can raise your hands and then I can call you to mute, and that's how we can have the question and answer session. Yes. So Ranjit Kumar, yes. Yeah, you can unmute and
Yeah, hi, Mr. Panda. Thank you very much. It was very nice to know all about this carbon emission and reducing the carbon from agriculture. I am from one of the ICR institute located at Hyderabad, named NARM, National Academy of Agriculture Research Management. So I have two questions. One is that probably you must be knowing that government of India is very much interested in natural farming, organic farming kind of thing. No, very dedicated schemes are there. However, that how much this carbon market, carbon credit is going to benefit the farmers, or how much it is going to motivate the farmers to go at a larger scale, and how individual smallholder farmers will get benefit from this one. And second question is that is there any no, credible example of livestock management through which we can reduce the GHG emission? Right, transitioning that food behavior, consumption behavior is little difficult and no very long run methods, but how at management level it can be done, and so that we can reduce it. Thank you.
Yeah. Shall I take some more questions or one by one,
if
brother?
you should respond to this and then.
Shall I take this one? Okay. Yeah.
Yes.
Thanks for the nice questions. And I think in the case of organic farming, as we all know, that if you really look deeper into the Indian carbon credit market now, it's really developing very fast. You know, even if you look at the wetland sector, even if you look at the forest sector, there are really a lot of private players, which was not the case 10 years back. And now a lot of private farms are really talking or rapidly going towards bringing this carbon credits out from different sector. And it is just told that natural farming is also kind of one way of reducing greenhouse gas emission, which I agree. But I'm not really sure how far carbon credit market can really do that. I'm not sure if that was the question, but there are still scope to do that, and which also talks to the private players, because for now in India we are uh, not really talking a lot about how private sector can really contribute towards this emission reduction. We are a bit kind of we always think that government will do all the things, but it's not the case. Sometimes we also need to bring the private players into play, where in the carbon credit market they can really play a role. And on the consumption behavior of the meat, I think that's a hard challenge. But as we discussed earlier, that there are also a lot of alternatives now, both in terms of technology and in terms of consumer behavior. Either you can use a lot of economic instruments, for example, tax, which is really hard in India, but we don't know, we have not experimented yet. So there are instruments to use, for example, like increasing the price in the meat. Just a simple example, you just increase the price of meat and you just reduce the supply. But apart from that, we also need to change a lot of behavioral aspects. We need to see, and we need to do more research on that, how behavioral things can be changed in the food consumption sector. That's one thing. And yeah, I think it will take some time, but we need to really combine both the technological development in the alternative food sector and also the behavioral aspects of consumers. Thank you, Ranjit sir.
Okay, thank you so much. Now, Anup Kumar De. Anup, you can unmute and
Yeah. Hello.
Yes,
Am I audible?
yes.
Yeah. Hi, Architesh. Myself, Anup Kumar De. I'm currently working as a Sustainable India Finance Facility Fellow at Raitu Swadhikara Samastha in Andhra Pradesh, Department of Agriculture. So they are promoting the natural farming. So regarding the earlier questions, I would like to ask that though the Andhra Pradesh government has started it since 2004, there are like right now 8 lakh farmers who are practicing natural farming, but still there are farmers were practicing conventional chemical farming. So, what should be the way out for the like behavioral change for the conventional farmer to shift to the natural farming? Like, is it some sort of a reward-based system, like carbon credit system, which is working for the industries, or some sort of incentives or the changes in the policies which is needed to shift this momentum towards the natural farming to reduce the carbon emissions or the methane emissions. That's what my question. Thank you.
Yeah, thanks for the question. I think it also relates back to my earlier answer and also the thing that we did not discuss very detailed in the slide. That was I was talking about agricultural subsidies. As you just said, if you want to make a transition from the conventional agriculture towards the natural farming, and if that's beneficial for the farmers, there are a lot of adversarial subsidy system in agriculture, not only in India but also in the whole Asia, where they're trying to provide subsidies to the things that really contributes to our emission, and the chemicals and fertilizers is one among them, and there is large amount of subsidies going into that sector towards making it more available to the farmers. So I think one way of looking at that is to how can you use the economic instruments, for example, reducing subsidies, where the debate is still going on at the global level, how we can really reroute these subsidies toward making it more greener. So I would say that economic instruments like subsidies really play a big role in terms of the shift from one kind of agriculture to the different kind of agriculture. Thank you.
Okay, then we have Rohit the Vasist.
Hello, Architesh. I'm Rohit from Himachal Pradesh. I'm currently doing PhD from Dr. Y.S. Parmar Institute, that is an ICR institute. My question is regarding that we all talk about the carbon credits and carbon market, but don't you think that there is a lot of complexity in to maintain this carbon market, because we know that the agencies that verifying the carbons that are where our gold standard these are and also the ground reality that the farmers field are different, and some the consultation institutes are different, so there is a lot of networking needed to maintain this carbon network or carbon marketing. So don't you think it is very difficult to put into the farmer shoulder that it is very difficult?
Yeah, thanks for the question, but I don't look at it that way. I'm not really putting all my hopes on the private sector players in the carbon credit market myself. I'm not putting really all the hopes in that. But at the same time, I think we also need to think about the institutional rules that are in place, the legal rules that are in place. And for India, I would say the carbon market, credit market is still developing, and we don't really have a concrete institutional setup and a legal setup to do that. So I think that can be a good starting point. Right now, from my experience, I see that it's really they're working in different sectors, different rules. They just want to earn some carbon credit. There is not really this intention to go green, but really just to enter the market for the private players. Although there is the large potential, but I still miss the institutional and legal setup that needs to be in place to control all these things and regulate all these things. So that I think that's the first starting point. Otherwise, you will see after 10 years a lot of private players like doing different kind of things in the credit market, and we're not really achieving anything tangible out of that.
Thank you.
Okay, any other question? Kingly Genius. Kingly. Yeah, Kingly, have you raised hand? You can unmute if you want to ask question. No, okay. I think he's not going to ask. Anybody else who wants to ask any other question? Okay. Before anybody asks, then let me ask a few questions. So first of all, like some people are talking about this organic farming, and I would like to know from you whether there are clear-cut evidences that organic farming has less emissions compared to the chemical farming that we are doing, or the modern intensive farming that we are doing. That is one. Then coming to the second question, that again livestock farming actually is a major contributor to the methane gas emission. Now again, uh, is industrial livestock farming. I'm saying industrial farming because earlier also we had livestock and animals, okay? And now we are putting it together and we're intensifying this. So, is it this industrialized livestock farming contributing to the more emission, and how do we sort out this issue? Because in India, like as you have pointed out, we have the challenge of food security as well as nutritional security. And if you see in India, like the poultry farms have grown exponentially in our country, and I think that is also a major source of emission, right? And are there any scientific methods in which actually we can still produce more meat and more milk, but we reduce the carbon emission? So if you can throw some light on that, then I would, because I'm not a student of agriculture, no economics or agriculture science. I know there are many participants who are agriculture scientists. So either I think you, if you have some evidences or if there are studies, you can share with us.
Yeah, thanks, Amaranta, for the nice and tricky questions. The first one is natural farming. Of course, there are a lot of studies. I don't have those in my mouth now, but there are evidences to prove that natural farming is really kind of better than the chemical and fertilizer use. Because if you simply think about it, if you reduce the chemical and fertilizer from the whole chain of farming, it's already having an impact on the emission, right? So there are scope, and I have also read in a few places that in some places in India, people are already reaching the threshold, because if you do intensive cultivation, eventually you will end up at a time where the land is no more fertile to give you any production, right? And then at that point, you have to go back to the natural farming, like using the cow dung to regenerate the nutrition in the land. So I have seen that in many of the places in India. I have read it that some of the agricultural sectors sections are already reaching the threshold of using this highly intensive agriculture, and they are slowly coming back to natural farming. And it will happen eventually. It will happen. But yes, to answer the question, yes, there are evidences on that. On the second question that you asked, I think chicken comes at the end of the emission ladder. So I think it's beef and pork at the top. So beef is the highest amount of emission. So there are two things here. We are talking about also the consumption behavior, because in India we don't really have much of that. We have a large poultry, as you say. But as far as I understand, there are already a lot of
Interrupt you. Since you're telling that beef production causes more emission, like is it just keeping, say, the animals causes emission, or something of the
no,
uh,
no.
causes emission? What real causes the emission? I don't understand.
The causes emission is from the stomach of the livestock. It's the entering fermentation. So how do they
So forget about the milk. Even if you keep the cows and bullocks, then also you have methane emission, right?
Yeah, yes, the highest one is beef and pork.
Okay.
Chickens comes in the last. But there
Okay.
are also technology, as I said earlier, there are already technologies to reduce the enteric fermentation. I think ADB is already doing a lot of experimentation in Southeast Asia on this, how to use technology to do this. So And also, as far as I understand, New Zealand is a big player in this livestock technologies. They are doing quite a lot, and also Australia. So there are examples and evidence already, but we need to see how this technology can be transferred from there to here and how we can really adopt into our local circumstances. So right now for India, even if livestock is a big problem, big emission sector, I don't see really a viable solution in the next 1 or 2 decades because a lot of people are still dependent on that. So we maybe need to think how we can reduce emission from other sectors, let's say rice, but there is a lot of potential to do it, without really hampering the livelihoods of people. So we need to think about this, how we can really make this transition and adjust in different sectors.
Okay. Thank you so much. Then we can again go back to Kingsley. Uh, Wanted to ask question. Now, can you unmute?
Okay, I would like to ask you about
You
most
are
of
not
the
audible.
Indian.
Can you come a little closer and say louder?
Okay, most of the Indian farmers, they are marginal farmers, right? And they covers up to 64%. So we know this, these people are much reliable on their cultural activities and they depend on culture for their agricultural activities. So for the implication of these greenhouse effect of carbon emissions, they need to know these lessons, but there is this, they don't know how can we imply this knowledge of carbon emissions of these lessons to them. How can we do that? Because they are basically, some of them are not even, they don't even go to school, they don't even have some platforms to know about these things. So how can we imply, because that is where we are facing most of the emissions, like from the rice farms, from their animals. So what methods can we really do to solve this problem of emissions from them?
Yeah, thanks for the question. I think we also discussed a bit in the slide that it's not only all the technology, it's also about affordability and availability of the technologies and which should reach the small farmers. You asked a good question. We have available technologies, but how to make them more affordable so that a large number of marginal farmers can use them. And apart from that, I think also training and awareness is a big part in the whole exercise. We are not really, a lot of farmers are not really well trained to use these technologies or the available technologies and how can we really do that. So I think affordability of the technologies and awareness and education are really the kind of answers that I will give to your questions.
Okay.
Thank you so
Thank you.
much. Now, may I invite Dr. Chandrasekhar Rahinapati to put his question.
So am I audible?
Yes, you are got.
Okay, thanks for very much. Of course, I missed half of this presentation. I think what I guess that okay. So some of your questions I have heard that they are actually telling that okay about the organic farming. Okay, looking at the Indian scenario, so which basically we found in a recent paper taking the NISER 2019 data set in scientific reports. So actually, what will happen, whether it's sustainable, because when the budgeted allocation is there, 1 rupee on organic farming and there's a 10 million rupees for the pesticides or the chemical fertilizers, and the farmers are basically, if you look at the farmers' expenditure, okay, if you look at the low marginal, which is basically 80 to 85% of the total farmers' basket in India, so there most of the expenditure goes to the chemical fertilizer. Okay, if you look at the input expenditure, chemical fertilizer, and given that if so there's a less subsidized in the organic farming, and how the farmer will shift, because if you look compare the input with the output value, hardly there is any difference of the small and major farmers. Okay, given there's hardly any difference of small and marginal farmers with input and output, if the input expenditure increases with respect to organic farming, I don't think it's sustainable for the Indian farmers.
Yeah, thanks, Chandra. Again, the question about sustainability, I think it came from the audience that whether natural farming is compared to the traditional farming. I personally see a lot of scope, and as I discussed earlier, also people are all reaching the thresholds in some places in India where they really need to go back. And you rightly pointed out that subsidies to the chemicals and fertilizer sector is really big pushing factor for the people. And well, we need to think how we can really make the natural farming profitable for the farmers. We need to put some price instruments in place. Let's say, for example, give farmers more incentives who are doing natural farming, so that the price of the outputs will be more or at least similar to the conventional farming. So again, we need to think about economic instruments, what kind of economic instruments can be placed. And you also discussed about the budget a little bit, how government is spending their finances on this sector. So they need to ramp up the finance for natural farming. So these are the possible solutions I see. But I don't think it's really a non-sustainable solution. It is a sustainable solution, but we need to scale it up and reach a point where there is economies of scale, and farmers can really get the benefit out of it.
Thank you so much. Then may I now invite Dr. Shivendra Srivastav.
Thank you, Amrinder ji, and my compliments to the speaker on his very comprehensive presentation. I'm a researcher at Indian Council of Agriculture Research. I have two queries to the speaker. One is that he speaks about the role of subsidies on in emissions and other things. To a great extent, we do believe that have a significant contribution to the greenhouse gas emission. I want to know your response. The subsidies are also a measure to disseminate and adopt the technologies also. So rationalizing subsidies are being focused to a great extent nowadays. Are you aware about that at the international level, this how the rationalizing subsidies towards promoting the sustainable practices is picking up at the international level to counter this greenhouse gases? It means that substituting those technologies which are emitting to those technologies which are actually reducing the emissions through the subsidies and other public finances. My second query is related to the energy sector. Probably I missed that to what extent this energy use of energy in agriculture actually contributes to the total greenhouse gas emission. In case, if you can educate me that to what extent this, for example, the use of diesel and electricity used in India's irrigation or Asia's agriculture contributes to the total greenhouse gas emission, and substitution of these energies with the solar energy, which is actually being focused to a great extent. To what is that potential? That to what extent it can really contribute to reduce the greenhouse emission from your perspective? Thank you so much. And once again, I compliment your nice presentation.
Yeah, thanks, Dr. Shivendra. That's a good question. To your first question, yeah, as of now, there are a lot of developed countries. We are really subsidizing a lot in the case of agriculture. So, developing countries are still really in the bottom of the game. They are not really very high on the scale. So, that should start from the developed country, and that's what the whole pressure at the global level now is: how to reduce the bad subsidies or inefficient subsidies for agriculture, which doesn't mean that it's not happening in Asian countries. It's also happening in the Asian countries where they are trying to giving subsidies to things that really are not really sustainable for the environment. So we need to think how can we really accelerate this process of identifying those subsidies, the patterns. And there has been as far as I know, there is less research on this, like what kind of subsidies are more efficient, where do we need to put a brake, where do we need to reduce the subsidies. So I think that's the area where more research and more policies are needed for the subsidy sector. That's one. And to your question of your reducing emission from the agricultural sector, I think I talked in a slide about the food supply chain, which is one of the biggest contributor of greenhouse gas emission in the food sector. So food supply chain can include everything from production to consumption to packaging to end use things. So there is a large potential in this food supply chain for reduction of greenhouse gas emissions. For example, you can think how you can make the food supply more green. Let's say transport. When I'm talking about the food transport, is there any other ways that you can use? Let's say, for example, battery power food transport. Things like this. So there's a whole supply chain of this food production and consumption where there are large, low-hanging fruits to intervene and make it more greener. So I see there are scopes, but we still need to do a lot of work on that.
So do you feel that the food system approach is really going to work? Because the food system means there are so many complicated linkages and the whole system need to be transformed. It means that we need to take a policy decision for each different subsectors, different stakeholders at a time. So what do you feel that is it really going to work in a big complicated economies?
I think the shift is already happening in many of the countries, not so much in the middle income countries or low income countries, but shift is really happening in lots of in a lot of developed countries. For example, as I said, alternative meat consumption is, for example, one example in that which is really rapidly growing industry. Even if you go to Bombay now, you can see a lot of alternative meat packages in the mall. So I would be happy if the transformation will take place, and I also think that it's essential. The way climate change is happening, there is no other way than to transform the whole food system. I think that's the future if you want to do something and to avoid all the impacts of climate change.
Thank you.
Okay, thank you so much. Now, Subhangi.
Thank you, sir. First of all, I would like to thank NISER, DST, and Amarendra sir, and of course Architesh sir for such a nice presentation and opportunity to interact. My question is a follow-up question on like what we discussed with Shivendra sir right now. So when we are talking about the greener technology, like you told, starting from the transport, like food supply chain, at every point, if we try to make the agriculture or the entire supply chain sustainable, then probably we'll be able to achieve our goal of safeguarding the environment or lowering down the emissions. But probably my question is a bit out of context. However, it's related to this because when we are trying for any kind of greener technology, the price of the same also increases manifold, at least in a country like India. And where in a country where we have small and marginal farmers, and like recently when I went to Burgard also, I mean, that's the case where we use a lot of chemicals or a lot of additives in the agricultural sector, where we get easy production, higher production, but then the entire environment along with the health of the consumers are affected with it, right? So when we are talking about greener technology, like it is definitely possible in Western countries, but a country like India, of course, has to think about the economic perspective of the same. And if we are talking about the farmers to accept it, then like what could be a probable strategy? Because being a smaller marginal farmer, I think if we try to shift to cleaner technologies, because even if they have to take their food or they have to give the food to the wholesalers who will instead do the transportation with the greener technology, I think the cost of production will increase a lot, right? So what could be a possible solution towards incentivizing the farmers, we can say, or probably making the entire process economical, or that's what my question would be.
Yeah, thanks, asking this complicated question again. So there are a lot of things that goes into the picture. As you said, I also know quite a lot about Borgod and how the health situation are really bad now because of the water pollution there. And even if you go to get the vegetables in the morning, it's all chemical and fertilizer laden. So if you talk about that, I think the first entry point would be policy. I don't see that ourselves can really do a lot of in this. As you just said, that farmers have easy access to these things, and they just want to produce and get money. So I think it should start from the policy level. Let's say, for example, what government of Odisha can do in this case, and come out with a plan for the farmers in more stressed region. Let's say, for example, Bargod, as you just told, it's a hotspot in Odisha where you have the highest consumption of fertilizers, and they are really destroying the environment, and we are not able to do anything on that. So I think policy is the first entry point for that. There are also different leverages like price and, as we discussed earlier, price and subsidies. So there is no one. I would say there is no one magic bullet to solve all this problem. So we have to take into account what are feasible to start with. Let's say from policy we can start, then we can think about how to reduce subsidies, then we can think about how to raise the incomes of farmers from other livelihood sector, and not only make them dependent on the rice production for their livelihood. So there are different ways that you can do it. So there is no magic bullet for that, but policy can be a good starting point for me.
Thank you so much.
Okay. So thank you so much. I think if there are other questions, then we may wind up this because we had enough of discussion. And so the learning points for me actually is that we should promote more and more organic farming, and some technologies actually we should adopt. Basically, we should also, wherever actually we are using energy, we should move towards solar energy. And but then it remains a big challenge because food security is the major concern, and promoting organic farming is also not that easy, because farmers are equally worried about their production and losses. So we don't know how do we move towards the organic farming or the natural farming. So, but in fact, I was also thinking whether we should worry at all actually, because when industry and energy sectors are contributing more actually, carbon and without actually industrial emission and energy emission, probably we can live, but without agriculture we cannot live because this is basic thing. So I think probably our priorities should be more on industry and energy sector, but of course we cannot ignore agriculture, because agriculture is contributing huge way to the carbon emission. So I hope we have, since we have a lot of agriculture scientists who have joined in this lecture, they would think how to promote low carbon agriculture technologies, and at the same time we also ensure the food security of the nation and also nutritional security. So so with that we may conclude, and I sincerely thank Dr. Architesh Panda for spending his valuable time with us and sharing his knowledge. And I really look forward to meeting you in Bhubaneswar. Whenever you are coming to Bhubaneswar, please let me know so that we'll have more discussion. So thank you all the participants, and who could also join with us and who had very good interaction with the speaker. And I also thank Dr. Chandrasekhar Bahinipati for establishing the contact between Architesh and me. So with that, we may close. Thank you so much.
Thank you, everyone. Thanks, Amandra.